Good morning, dear students. We will now start our new lesson. It's chapter 1, Energy.
The objectives of our session today are: define energy, understand the law of conservation of energy, and finally determine the kinetic energy of a system.
First, what is energy? Energy is the ability to do work. After doing a big work, one feels tired since a lot of energy is used in this process. The unit of energy is joules. Its symbol is J capital. We should know that energy has no mass, does not occupy a space, and exists in different forms. What are these forms of energy? Some of these forms are written here. Energy can be found as sound energy, light energy, heat energy, electrical, chemical, nuclear, magnetic, mechanical, etc. If a system is able to do work, then this system possesses an energy. When work is done, energy is transferred from one form into another, or transferred from a body to another. So we should pay attention to the law of conservation of energy, which says that energy is neither created nor destroyed. It transfers from one form to another. Mechanical energy. The energy possessed by a body due to its state of rest or state of motion is called mechanical energy. Actually, we have studied mechanical energy in grade 11, but we will make a revision about it. Mechanical energy is of two forms, kinetic energy and potential energy. What is kinetic energy? Kinetic energy is the form of energy possessed by a body or a system due to its motion. So any moving system possesses kinetic energy. Kinetic energy is of two types, translational kinetic energy and rotational kinetic energy. Translational kinetic energy is the energy possessed by a moving object in a linear displacement, or in translation, its formula or its value could be calculated by half mv square, where m is the mass of the object, which is measured in kilograms, and v is the speed of the object measured in meter per second. Rotational kinetic energy. It is the energy of a rigid object in rotation about a fixed axis delta. Kinetic energy can be calculated by K equals half I omega square or theta prime square, where I is the rotational inertia of a system, which we already took last year, but it will be given simply this year, and omega or theta prime is the angular velocity or angular speed. Notice from the formula that kinetic energy is never negative. Half mv square or half I theta prime square will give always positive values. This is an application how to calculate the kinetic energy of a system. The system consists of a wheel of mass m equals 20 kg, of center of mass g, and radius r. The wheel rolls down an inclined plane with a speed of Vg equals 2 meters per second at a certain instant t1. So you are supposed to calculate the translational kinetic energy of the wheel, the rotational kinetic energy of the wheel, and then the total kinetic energy of the wheel. The translational kinetic energy is calculated by half mv squared, as shown in the solution. Its value is 40 joules. The kinetic rotational energy is calculated by half I theta prime squared, where we replace I by its value half mr squared, and theta prime, which you all know that theta prime equals Vg over r, and then squaring it, we get kinetic energy rotational equals 20 joules. So the total kinetic energy is simply the summation of the translational and the rotational kinetic energy equals 40 plus 20 joules equals 60 joules. Now suppose that the wheel slides without rotation, just sliding without rotation, along the incline and reaches the bottom with a kinetic energy of 60 joules. Calculate the speed of the center of mass of the wheel at the bottom. Since there is no rotation, theta prime equals 0, so kinetic energy rotational equals 0. We have only kinetic energy translational, which is half mv squared, so that I can determine Vg by the formula radical 2 kinetic energy over m equals 2.45 meters per second. Thank you and have a nice day.